All right, so today our objective is the Pythagorean theorem and how to apply it in real-world situations. So we know that our Pythagorean theorem states a squared plus b squared equals c squared, where a and b are those two legs that form your right angle. So these are our legs, a and b, and that c is that longest side directly across from our right angle. So the sum of those two legs added together, is going to equal, the two legs squared is going to equal that third hypotenuse, the third side, that hypotenuse, the longest side squared. All right, so I'm going to go ahead and read through this. I'm going to explain my thinking as I go, what I know. I'm going to plan and work it. I'm going to figure out what I need to know. And then I'm going to have you set up your next one and then solve it. All right, so Bethany has a circular tabletop that she needs to carry inside her house to paint. Her front door is a rectangle. So the first thing I'm going to point out is that I know that we're talking about a rectangle. So I know her door is a rectangle. What that tells me is that there's going to be a right angle. Her door is a rectangle. Here's a rectangle, which has a 90-degree angle. And a 90-degree angle equals Pythagorean theorem because we're going to have a right triangle. So I know that that's her door. We know that her door has a height of 80 inches. And we know that it has a width of 36 inches. In order for the tabletop to fit, it has to be at least 86. So we need to know if the doorway has a diagonal more than 86 inches. We're talking about inches. So my plan for most of the my plan for every single Pythagorean theorem problem I have is to draw it out so I can see what I'm talking about. So this is her door. Looks like a regular door, you know. Here's these, but these are irrelevant, but you know, a door. So that's her door. Well, they told us the height of her door is 80. The width of her door is 36. In order for this table to fit, she needs to be able to turn it and have that diagonal be 86 degrees. I can tell that this angle of the door is 90 degrees because it's a rectangle, and the corners of a rectangle are 90 degrees. So I know my two sides that form that right angle. My diagonal is not very straight because it looks like we have part of it that's not. All right, we're just going to have a pre-drawn door so it looks better. All right, so there's our door and our diagonal. And I cannot see it in front. Okay, so our diagonal that fits in our door. All right, so we know that the height of the door is 80 inches. The width is 36. We need to know if she can turn her table, and this unknown diagonal needs to be 86 or more. So we know a doorway, this is going to be our right angle because it's a rectangle, and the corners of a rectangle are 90 degrees. So we know the Pythagorean theorem states that the two legs, so the two sides that form that right angle, squared and added together equal, in this case, the unknown, the hypotenuse squared. So we're going to go ahead and say 80 squared is 6,400 plus 36 squared is 1,296. Is going to be equal to our diagonal squared. So 1,296 plus 6,400 is going to give us 7696 And that's going to be equal to our diagonal squared. But we want to know, if I turn that table, is it going to fit in the door? So I need to know what the square root of that is. So I'm going to get 87.7. So what that says is that if she turns her table and her table is only 86 inches, but her diagonal is 87.7, we have plenty of room with a little bit of buffer way to get that table in, because the diagonal of that doorway is 87.7 inches. So my solution is that yes, the table will fit, because it only needed to be 86 inches, but we got 87.7. Yes, table will fit with room to spare. All right, so now what I want you to do is I want you to read this. I want you to figure out what you know. I want you to plan and work. And in your plan and work, I want you to draw out your diamonds, your baseball field. Because once you draw it out, you should be able to see where we're going with the Pythagorean theorem. Write down what you need to know and figure out your solution. So pause this, read it, fill it out, work it out. Did you do it? Then pause it. All right, so I read it, and what I put that I knew was, well, first off, I know that this is a square, and a square has 4 90-degree angles. I also put that I know that each side is 90 feet. So, and then as I'm doing that, I'm putting what I'm planning and working. So I know this is 90 degrees. And I know that this is 90, this is 90, this is 90, and this is 90. And I had to think about it because baseball didn't come straight to me. It told us that he threw the ball from home to second and then second to third. So I literally said, okay, home plate is here, first base is here, second base is here, and third base is here. So if he throws the ball from home plate to second, that's our diagonal. We don't know what that is. And then he throws the ball from second to third. We do know what that is. So if I can figure out what the diagonal is, I can find the distance from home plate to second and second to third and add the two together. So I have a right angle, and I have 2 of my 3 sides. So I know that our 2 sides that form our right angle, added together and squared, are going to equal that unknown home diagonal, so home plate to second. So I can go ahead and say 90 squared is 8100 plus 8100 equals our diagonal squared. So 16,200 is equal to diagonal squared. So if I went ahead and plugged in my calculator and said, what is the square root of 16,200, I'm going to get that the diagonal is 127.3. But what it asked me to know was second base to third and home to second. So what I need to know is home to second and second to third, the distance. So now I can go ahead and say, well, home to second is 127.3 plus second to third is 90. Put 0.0. So I'm going to get 217.3. feet. right, so now we're going to work out some more problems. Just this time, the big important thing is that we're going to use our diagrams, and we're going to plan and work as we go. So it tells me that she wants to put a ribbon border around a sign in her classroom. So this is her sign, is a triangle, and there's our right angle. So it says ribbon costs 82 cents per foot. How much will it cost for her to build a floor sign? Well, before I can multiply 82 cents per foot, I had to figure out how many feet I need. And I'm missing a side. So I'm going to use my Pythagorean theorem to figure out the length of my missing side of my right triangle. I know that my two sides that form my right angle, squared and added together, will equal my third one. So I know 6 squared plus 8 squared, a squared plus b squared equals my missing hypotenuse squared. All right, and then I can go ahead and say, well, what is 6 squared? 6 times 6 is 36, plus what is 8 squared? 8 times 8 is 64, is equal to my third side squared. Well, that's 100. But I don't want x squared, I want x. So if I take the square root of that, I get that my third side is 10. So now I know how much ribbon is all the way around it. I have 6, I have 8, and I have 10. So in total, the entire perimeter of that sign is going to be 10 plus 6 is 16 plus 8 is 24. So we have 24 feet. But I want to know how much costs to buy 24 feet of ribbon. Well, I want 24 feet, and it costs 82 cents per foot. So 2 times 4 is 8, 2 times 2 is 4, 8 times 2 is 32, 8 times 2 is 16 plus 3 is 19, and we get that it's going to be 1968 to wrap that whole thing in ribbon. Do we see that? Cool. All right, so here's what I want you to do. 4 gives you the diagram. Plug in what you know. Make sure you realize that when it says 10 meters, that this is 5 and 5. That 10 meters is the entire bottom of that base. They give you the information in the chart. We did one just like 7 already. So make sure you know that you're using the perimeter, but you only want one side so that we can find that missing side. So you can use it as one of your leg lengths. Look, go ahead. Read 4, plan it out. Read 5, plan it out and solve it. Use the diagrams. Once you have the diagrams, use your Pythagorean theorem. Make sure you're giving it what you asked for. Some of them you're just solving your Pythagorean theorem. Some of them you're going a step farther. Read it out, plan it out, solve it through 8. And then go ahead and unpause this because I'm about to go over them so you can check your answers. All right, so number 4 says in the isosceles triangle below, the congruent sides each measure 13. So here's our congruent sides of our isosceles triangle. It tells us that the base is 10, so that gives 5 for each side. So, and they already give you your right angle. We know these two sides that form it, so x squared, squared and added together, our two legs, equal our hypotenuse squared. So x squared plus 25 equals 169. 169 minus 25 is x squared equals 144. So we're going to go ahead and take our square root of both sides. And this height is 12. Is that what it's asked for? What is the height of the triangle? Yes. Our height that we did not have is 12 meters. Did you get that one? That one was fairly straightforward. They didn't ask us for anything. They gave us a triangle, and we just solved it. Awesome. So then the next one says a square sandbox in Trisha's backyard has an area of 81 square feet. Well, first off, in order to find that diagonal length, I need to know what those side lengths are. So, area of a square is side times side. So, if we take the square root of the area, we'll know what the sides are. Well, the square root of 81 is 9. So, each side is 9. And then we want to find the diagonal length. So, this is just simple. Our legs squared and added together equal our missing diagonal. So 9 squared plus 9 squared equals diagonal squared. So 81 plus 81 equals x squared. So 81 plus 81 is 162. And then the square root of that is going to give me that diagonal is 12.7. Did you get that right? Do you see what you did wrong? If you didn't, put a star there and ask me in our small group. All right, so this next one says, to walk to her friend's house, Julie normally walks 63 yards north and 16 yards east. How many yards shorter would it take if she took the diagonal shortcut? Well, first, 63 and 16 gives me 79. Currently, she walks 79 yards. I know that. But now I want to know if she goes here instead of north and then east, how much shorter is that? So we want to know how much shorter the diagonal is than 79, because that's our 63 and 16 she's going already. That's what she's currently walking. But I know that this is a right angle, and that these two sides that form our right angle, squared and added together, are going to equal that third one. So 16 squared plus 63 squared is going to equal our new route squared. So we can go ahead and say that 16 squared is going to give us 256. And then plus 63 squared is going to give us 63 squared is going to give us, my calculator. 63 squared gives us 3969. And then we're going to go ahead and add the 256 to that. So 42.25. And we take the square root of both sides to find the length, the diagonal. We are going to get 65 yards. So how much shorter is 65 from 79? Well, 79 minus 65 leaves us with 14 yards shorter. All right, 7, we did one like this already. And it says that the perimeter of the square 3 is 36 units. Well, perimeter is side plus side plus side. So side times 4. So 36 divided by 4 means that each side is 9. Same thing with square 2. It says the perimeter is 48. Well, that's 4 plus 4 plus 4 plus 4. I think that was 4. 4 plus 4 plus 4 plus 4. 4 fours. So 48 divided by 4 is 12. So each side is 12. So in order to find the area of square 1, we're going to do our Pythagorean theorem. So leg squared plus leg squared equals our c squared. 9 squared is 81 plus 12 squared is 144 equals that third one squared, c squared. Well, 81 plus 44 is going to give me 225. But I want to know what the square root of that is. The square root of 225 is 15, I believe. It's 15, so that third side is 15. And I could have left it squared because we know that the area is sides squared. So 15 times 15 is going to give me the area being 225 units squared. So if they wanted the side, it's 15. They wanted to know the area, we have to square the side to get 225 because 225 units squared is what they asked for. All right, so then our last one. It says that he's building a garage in the shape of a rectangle. It says that the width is 16 feet, and we know that a rectangle, these sides are the same, and the height is 8 feet. He wants to place 2 boards in the shape of an X in those diagonals. Well, since it's a rectangle, I know those diagonals are the same. So if I find one, I can just double it. So I also know that a rectangle has a right angle. So 8 squared plus 16 squared is going to give me this diagonal. And we already just decided that because it's a rectangle and the top and our bottom, our width and our height, our width is going to stay the same and our height is going to stay the same on both sides. But I'm going to find one diagonal and then I'm going to double it because they should be the same length. So I know that our legs are 2 sides that make up this right angle. So this one and this one. So 8 squared plus 16 squared is going to give me my diagonal squared. 8 squared is going to give me 64 plus 16 squared is going to give me 256. And that's my diagonal squared. 64 plus 256 is going to give me 320. And in order to figure out what my diagonal is, I have to take the square root of both sides. So the square root of 320 is going to give me 17.8. But we need 2 of those. So 17.8 times 2. And so we're going to get about 35.6 feet for those 2 diagonals. So think about your Pythagorean theorem. Think about the strategies we use. We set up what we know, what we need to know. We came up with a plan. So the big thing with Pythagorean theorem is drawing it out. So think about your objective and how we did that objective and use that in your summary. Talk about what the Pythagorean theorem is. Talk about how you use it to solve word problems. My big thing with Pythagorean theorem and the real life examples of it is drawing it out so you can visually see. I'm a visual person. When I'm doing Pythagorean theorem, I like to see it. Draw it out so you know where your right angle is and you know which ones are your legs and which one's your hypotenuse. So use that objective to fill in the summary and then submit your guided notes on this. If you feel like you're comfortable now, you can go ahead and do the homework on this. Otherwise, you can go ahead and make sure you come to our guided practice. If you got any of these last couple wrong that I had you do by yourself first, bring questions to our guided practice. And I will see you guys later. Have a great day.